Okay, after open the Tekla Structural Designer, you see this window. Okay. Okay. So now look into the menu, right? File menu is a common. You can create a new or you can open the existing projects, right? Then other menus I explain later on. So I am going to create a new projects. Okay, wait for a while. Okay, now the project is ready. Okay, look at the project browser, right? Actually, this one also, the window also is quite similar to Revit Structure. That's why I choose this software. So Windows and model type of modeling is quite similar, right? So look at the project browser, right? You see Structure. Here you're gonna see other things. Only we have Structure. So Structures means we have the levels, right? Then if we have submodels or substructure, we can have it here. At this moment, we don't have anything. So later you can see column and beams here, right? So now we have the levels, right? So below is the properties, right? So now is we have only the structure, right? So we have level only. You can see the level property. So what is the level, flow, or what's the type? This one I come back later on. Slab thickness and so on, right? You can define here, right? So these are the properties. Okay, quite similar, same as Revit structures. Okay, so the first step is we have to decide how many story we are going to model it, right? So let's say I'm going to model 3-story building, right? Base I decide as a foundation, right? So first story, second story, and third story. So in order to create the levels, right? So I had to go to model menu. Okay, beam integration, I come back later on. Right, so we don't need to call the beam integration first, so I can come back later on when we do the integration. Okay, before create the levels, I quickly go through the menu, the core menu, right? Is quite standard things. You see under file menu, you can see here also, but there's some other setting also. Basically it's a model setting, right? I quickly run through the model setting and you can understand more. Okay, I got to model setting. So here you see this is a general model setting. So here we can set what kind of the code you want, what is the tolerance, what are the load combinations you want to use, and so on. You can define here, right? So design code, right? So here you can choose all type of the codes, right? So basically it's covered Australian code, Euro code, Indian code, and American code, right? Also is cover BS code, right? If you want, you can choose BS code, right? Basically, Euro code all are same, but Singapore Euro code means Singapore annex. British means United Kingdom means UK annex, right? So basically code is same, only annex is different. So I choose Singapore, or I can choose United Kingdom, or I choose United Kingdom. Okay, that's an annex. Right now you see accent, right? I believe you all of you are familiar the name. What's the meaning of accent? Accent means loading. In our old BS code term is loading, but Euro code term is accent, right? So accent code, right? So general loading we take from 1991 -1 easy Euro code 1, right? Bill load we take from Euro code 1 part 4. Synoload we don't need to bother this one. Seismic also I'm not going to discuss, so we can ignore it. But then finally is a load combination. Load combination we had to take from EC0. Okay. Here also there's a version, right? So the year which year release. Anyway, this is the latest, so we are following the latest. Then we go to the units. Okay, units. You can set up your units here. Dimensions, distance. Actually, we don't need much. Okay, there's a 2 dimensions. Dimensions and fine dimension. Normally, dimension this one means is a grid lines or major dimension. This one means section size or member length. Then deformation, area, modulus. Okay, if you want modulus millimeter square, millimeter cube, you can change it. Second moment type area or inertia, right? Bobbing coefficient, mass, load kilonewton per meter, force kilonewton, moment kilometer meter. All these ones you can change, but it's a quite standard, so I leave it, right? So I leave it all these one, right? Okay. Then the precision. If you want, you can increase the precision, right? So let's say deflection, right? If you want 2 digit, you can change it. Okay. Okay. Then got the reference. Okay. Uh, okay. So this one's something advanced. If I explain now, you may not understand clearly. So if I have the time, I come back later on, right? All this one, right? So loading, right? Okay. So it's a loading also is how to apply the loadings, right? I come back later on because all are the advanced settings. Okay. Minimum lateral loads. Okay. Normally, Eurocard, right? You had to design for equivalent horizontal load, EHF. We call EHF, equivalent horizontal load. The all time in the BS code we call as a notional loads. Those familiar BS code, they know this terminology, notional loads. But in Eurocode, there's no such thing, notional loads, right? But if you want, you can define the notional load here. There's a provision, but it's not mandatory in Eurocode. Actually, there is no provision in Eurocode. Eurocode did not talk about the notional loads. But all time, there's a practice, we apply the notional load. Normally, we apply 1.5 time by 1.5 percentage of the dead weight of the building. Each floor, we apply this notional horizontal loads, right? But it's not mandatory, right? But there's a provision. If you want, you can do it, right? Okay, so if you want, you can use this method, right? Some countries, they have these conditions. You have to take either, sorry, you have to take worst case scenario, minimum lateral load or will load. So there are some countries still they have these requirements, but I don't think Sri Lanka has this requirement. I'm not sure, sorry, I'm not sure. But it's not mandatory in Eurocon. So it's you supposed to decide it based on the country's design requirement, right? I choose it none. So I'm not going to choose this method, right? So basically I'm going to use EHF, equivalent horizontal load, because it's based on the Eurocode, right? So you see, yeah, basically, right, you can change this all height and everything automatically calculate. When you draw the building, after you model the building, if you come back and see, right, it's automatically calculate, right? So look at the factors. This is factors different. The nozzle load, right, is 1.5 times dead load. But here the factor is 0.5 times, right? 0.5%, sorry, 0.5 percentage, right? This is an ultimate load, right? If you design, sorry, if you use Eurocode, right? There's a under section 5 of EC2, they clearly explain how to calculate the equivalent horizontal load for the whole building or for the column, individual elements. Right. So worst case scenario is 0.5 percentage of the ultimate load. So it's calculated accordingly. If you want, you can override it. You can, okay, if you want to go more precise value, or if you want to go, if you want to calculate yourself and input it, then you can override here. But I leave it first. Then imposed load reduction, how to reduce imposed load. Similarly, right? These factors already covered in the code. If you want to change it, you can change it. Okay. This basically is a standard value given in the code. If you look at the easy one, then you can understand how to reduce the imposed load. It's based on the number of stories. Sway or trip. Okay, it's again same Eurocode, right? There's a value in the Eurocode, so you can change it. Alpha critical, basically. If you want, you can change it. I leave it all as standard value. Grouping, you can do the grouping. I don't do now. Materialist, beamline, this one I think not necessary at this moment. Structural beam become later on. Okay, so I click OK. Then manage property test. If you want to create any property group, you can do it here. So it is all we can do it later on. Then I go to setting, right? So this setting, right? Just I want to show you only where you want to do the works, right? That's my purpose, right? Right? Because basically, if you follow the standard things, right, then you don't need to change anything, right? So basically here you can see what are the settings you have done it. So basically what you want to check is design setting and analysis setting, right? So design setting, right? Normally you have to go to concrete because we are going to the concrete, right? So look at the concrete setting. What are setting they have it, right? So here you see there's a limitations, right? Normal weight concrete, maximum you can go 50 MPa, right? You could go more than that. So there's a limitation. So if you are familiar Eurocode, come back and look into it, right? So these values actually you can change it. Minimum bar size, maximum bar size, minimum side bar, cover, clear spacing, everything can be changed. But I'm not going through now. When we do the detailed design, then we can come back and modify it here. Okay, so I am showing you how to modify the parameter. So basically these are all are quite useful for detailing. Right. Later I'll explain to you how to do the detailing. After designing how to do the detailing, then you can understand how to change these parameters. Those very familiar on the design, then you understand how to do the changes here. But not familiar, don't worry. When we go to do the actual design and detailing, then I can explain there. Okay, so this place you can do that setting, design setting, similarly analysis setting, right? So and I don't want to go very detailed in the analysis because it's very deep section. I just want to cover only first order linear analysis. I don't want to look into it non-linear analysis or seismic. I'm not going to use any seismic forces, right? So I simply use first order linear analysis, right, for concrete building. So other settings, everything you can find out here if you want to change it, right? Then materials, right? Materials, right? We had to find out basically is a steel, right? So steel you can find out here what are material we have it, right? So if you change the code, you can see how it's changing, right? So at this moment, I think we don't need all this one. If you want, you look into it only the reinforcement, right? Right. So look at the reinforcement. What reinforcement we are going to use? 500. Right. Eurocode generally 500, but some country is still they haven't updated to 500. So it's I'm not sure the Sri Lanka really. So yeah, I'm not sure whether still they are using 410 or 460. So if you want to reduce your strength, then you can change it here. Right. Okay. Okay. So now let's go into the modeling. Okay, first steps, we had to set up the levels, how many levels we want. So we go to the model menu. So now you see the construction levels, right? So click the construction level. First level we call base. We can give any naming. Okay, I'm going to rename it foundation. Okay, so level I make it -1 because first story I want to call as a 0. Okay, then I'm going to insert another label above, right? So this one I'm going to call as story 1, right? So this one I make it 0, right? 1 meter. Okay, so let's say if you have any uniform thickness, actually you can enter here, but I'm not entering. We can modify, we can add the slab later on. So second story, I call story 2. Story 2. This just naming, actually you can name your own things, right? So this facing is floated floor height, I make it 4 meter. Okay, so is 4 meter. You see, -1, 0, 4, level 4. Okay, then I add one more floor by story 3, right? So it's automatic calculated 4 meter spacing. If you want, you can change it. I keep it 4 meter, right? So this is my basic 3-story building, right? Actually 2-story plus 2, 3 floors. Okay, I click OK. Now, okay, now okay, whatever things you want to do the modeling, better do in plan, right? Don't try to do in the 3D, right? You can do in 3D also, but better to do in 2D, right? First step is like Revit structure. We had to draw the grid lines, right? In Tekla structure, right? We had two options. One is called grid lines, another one called construction line. Okay, grid line is normally we use for the general drawing grid line. Construction line normally we use, let's say if we want to add secondary beams, then we do the construction line. Actually, construction line, you can off it. Later on, you can off it, right? So if you want any temporary or any lines to construct a drawing, then you can use a construction line. Okay, first I draw the major grid lines. So what I'm going to do is in the horizontal direction, X direction, I'm going to draw 5 grids in 9 meter spacing. In vertical direction, Y direction, I'm going to draw 5 grids in 6 meter spacing, right? So click on the, okay, before that, I click on the drop down. Now you can see the type of the how we can draw the grid lines. First one is a grid line. You can just draw a grid line. Then parallel means you can take the offset, right? Perpendicular means you can take you can draw another perpendicular lines. Rectangular wizard means you can draw. Okay, let's say if I have a rectangular pattern, I can provide the dimension, then it's automatically created. Sectoral same. And if you want the angular grid line system, then you can do it. If you want the arc grid line, you can draw it. Okay, I just draw the normal grid lines. So click. Okay, it's asking pick point. I pick the point, go straight, and finish it. Okay, so it's automatically say grid line A. So after escape, right, I select the grid line. Now you can see the properties. See name A is automatically. If you want, you can use it. You can give another name. If you want, you can change it the name here. I don't change. This is a grid system name, right? Style dash line. You, if you want, you can change the solid lines. Right? I keep it. So name. Okay, you can say start, end, or both. So I am going to keep on top. So I say end, right? So end only. Okay. Then grid name type is alphanumeric, right? If you want to change numeric, you can change numeric. Okay. Now I am going to draw another 4 grid lines, right? So it's a 9 meter spacing. So I use a parallel, right? So I choose this one, right? Then 9 meter. So you can enter 9 in the box. F2 9 meter, 9, enter. Okay. So now you already draw it. Sorry. Uh, sorry. I made a mistake. I delete first. Okay. Click here. F2, click F2, press F2, 9 meter, enter. Right now you had to start a row. Okay, then okay, now it's a second one is 18 meter, right? Enter the 18 meter, right? So pick at the first point, pick at the second point, enter. Okay, then you go to second 18, then 27 meter. So press F2, 27 meter, enter. So now pick at the first point and second point. Okay, 27. Next one is 36. 36 meter. Enter. Pick at the first point and last point. Okay, now press escape. So you have all grid line systems. Okay, we can adjust later on. Okay, never mind. So we adjust the name first. So I change to one end only. The change to end only. Okay. So yes, I'm setting up my grid lines. Okay. So if you want, you can adjust this one. You can move it. Actually, you can move it here. Okay. This is one grid line system. Okay. Next one, horizontal grid lines. Okay. So now we go to the horizontal grid line system. I wrote this one first. Okay. So it's a one. So automatically say one. Why cannot change? Uh, okay. Sorry. I choose it start. Start only. Okay. Okay. I got the same system. Actually, you can use parallel quickly also. Actually, you can pick here. You can move this way, 6 meter. So press F2, enter 6 meter. Right. Then press F2 and 12 meter. Right. Then go to 12, then 12 plus 6, 18 meter. 18 meter. Okay. So I go 24, maybe. I press 24, enter 24. Okay. Finally escape. Okay. So I adjust this one first. Why not adjust? Okay. Simulation. This one also adjust it. Okay. So now I have the grid line system. Okay. So okay. So this one you understand, right? It's similar to Revit structure. You first you have to draw the grid lines. Okay. Now we are going to draw the columns, right? Column actually you can draw from below to above or above to below. So actually you can draw bottom to top or top to bottom, right? So now I am going to draw bottom to top, right? So to column, right? Okay, here we have two options: steel, concrete, and timber also, right? So I'm going to use only the concrete. So I could select the concrete column, right? It's okay. There's a precast column also, but our building a cast institute, so I select the column, right? Once you select the column, you look into the properties. Okay. Okay, it's asking base level, what's the base level and what's the top level, right? If you want, you can draw the one straight column. But here benefit is even you draw one full column, after you draw just beams and slab, right? Column is divided. So you don't need to worry about the finite elements, whether it's considered as a full column or it's divided between floors. If you draw the beam, it's automatically divided. So I'm going to draw the column from bottom to top, same size, right? Easy, we can do it. Then character is a column. Actually, you can use as a beam brace also. Next time, let's say steel. If you want to use only the bracing element, then you can change it, right? But it's a concrete, so it's a column, right? Material concrete, fabrication cast in place, right? Then this all are standard. Then come to the concrete class, concrete grade. Okay. Okay, it depends what concrete grade you are going to use it, right? Okay, so this one, most of you familiar, right? 30 to 40 mean 32 is a cylinder strength and 40 is a cube strength. So I'm going to use this one. If you want to use a lower grade, you can use it. Actually, you can choose from here, right? So I am going to use grade 40 concrete. Auto design, at this moment I disable it. Let's do manually, right? Next time you can do the auto design, right? Then exercise. Okay, now we had to do the amount exercise. Okay, I decided this exercise is 500 by 500. Or I decided 400 by 600, right? So this anyway is based on our design, own design. I just choose it, right? What is this major element? Let me see what is this major. Oh, sorry. Offset. Okay, we don't have any offset. Okay. Reinforced one. Okay. We use a type 2, the rib type of the rebar. We don't use a mild steel here. So type 2, class 500. Releases. Okay. So I had to discuss about the releases, right? This is important. Okay. Look at here. Top and bottom, right? So let's check the bottom first. Fixity, bottom, fix, right? So click here and see we have 4 options: moment, pin, fix. Okay, pin, fix. I think all of you familiar, right? What is the meaning of pin? What is the meaning of fix, right? Right. What's the meaning of moment here? Actually, this kind of the connection we normally be using in steel, not common in concrete. In the steel, when we do the moment connection, right, it can carry the moment mainly is a major direction. Minor direction, it cannot carry the moment. So then you can make the moment connections instead of fixed connection. Fixed connection means it can carry the moment, major, minor, also it can carry the torsion. That means fixed. But it can carry only the moment in the one direction, then you supposed to use moment, right? If you use the first option moment, you see the within bracket pin M set. So M set direction is act as a pin, right? If you choose the second one, pin M by direction is act as a pin, right? So that means that if you choose the first option, M by moment, it can carry the moment in the M by direction, but M set direction moment is 0. If you choose the second option, M set direction, it can carry the moment, M by direction moment is 0. Pin means totally moment is 0. A fix means both direction it can carry the moment. It's a concrete build, concrete beam, right? Yes. Any problem? Hello. Okay, let me continue. Okay, for concrete building, right? You can choose either fix or pin. You don't need to choose a moment. Generally, you don't need to choose a moment. Okay. Okay, now column bottom base is a foundation, right? So I am going to use a normal free footing or fat footing, let's say. Then generally we pin the connection. We don't transfer the moments generally. It's depend on the type of the building. Also, it's depend on the framing system. What framing system use it. But I decide is pin, right? So our foundation design is straightforward. Right, so releases okay. Okay, then the top is actually you leave it because the top, right, so it's a frame, concrete frame, so you calculate the stiffness based on the member sizes. Then you can leave it where the pin or fix, right? Okay, then there's another option, you see, cantilever end. Okay, these are quite useful for the beams. When I come to beams, I explain, right? So if you are modeling the cantilever beams, right, then you can assign which point is cantilever end. Then you can clearly assign it. Some software you can assign it. Then sometimes this carry the minor directional moment. Then it transfers as a torsional to the main beam. So it's create a lot of issues, right? So let's say E types, right? If you don't do the proper analysis, if you don't do the proper stiffness reduction things, right? Then it's a main beam carry the torsion. is very dangerous. I saw many models, people model it right without understanding. So mom, beam carrying the torsion. Worst thing is software ignore the torsion because standard setting normally, if torsion exceeds a certain amount, then software automatically ignore it, right? Then you completely do the design, but it's not workable. Okay, I leave it first. This one. So my column bottom pin top, I will leave it because it's taking the frame stiffness. Analysis and design control is asking whether you want to assume crack or not. I click yes. You can click no also. There's no much different for the column. Design parameters, right? Okay. This in actually is normally useful for the crack analysis, right? For normal non-crack analysis, this one not useful. Cylinderness. Okay. Cylinderness. Okay. For column, right? We had to calculate the buckling length, right? So this buckling length, okay, is based on your input, right? So look at it. Direction one is there. I click the drop down. You see brace and bracing. Okay. You got to understand the meaning of brace and bracing. Brace. Okay. Brace mean this element or in the column brace by another element. Okay, that means the column is laterally braced or laterally restrained by the another structural element. Generally, column is restrained by the walls, right? Our general principles, columns are braced or restrained by the core walls or shear walls, right? So our slabs are act as a diaphragm to transfer the lateral load from column to RC wall. RC wall transfer the foundation because influence stiffness of the RC wall is very rigid compared to columns. So we design wall as a bracing element, column as a braced element, but it depends, right? So sometimes we use column as a bracing element. Let's say a moment frame. We don't have the shear walls. Let's say our building, we don't have any walls, right? So our column suppose act as a bracing element. So the column is a moment frames. So it suppose act as a bracing element, right? To make it simple, I make it as a brace element. So I model some walls. So wall take the lateral loads. Okay. Similarly, direction two, direction one and direction two, I use the same system, right? The stiffness, right? Actually, you can ask software to calculate or you can input yourself. Let's say one column there, intermediately you have another floor. You have the confidence that this column buckling length can be reduced, then you can calculate manually input here, right? But here we don't have such thing, so I leave it. So program can calculate. Then stiffness, right? So the okay, I enlarge this one. So okay, stiffness, right? So when you calculate the okay, I wrote something because I'm not sure whether you guys all study this one. So I explain clearly first. So I share the uh, whiteboard. So give me a minute. I share the whiteboard. So I wrote something in the whiteboard. Stop sharing whiteboard. First disable participant. Oh, okay. Okay. I share the whiteboard. You. Okay. Can you see the whiteboard? Okay, let me share. Let me share. Okay, I think you can see the whiteboard, right?
Yes, sir.
Okay, then I continue. So I want to explain to you the principles. I'm not sure whether all you guys are studying universities or not. Sometimes universities, right? They may not cover these things, right? So I'll explain something first, then you can understand. Okay, let's say this is a column. I draw the floor. My sketch is not good, right? So this one I call level 1, level 2, level 3. This is a foundation level, right? So what I told so far, what I explained so far is this one I make it pin. That means there's no any moment transfer between column to foundation. But this is a continuous column. These are the continuous joints, right? So it can transfer the moment. So I expect this column supposed to behave like this. If you look at the bending moment diagram end of the day, so supposed to be like this. So I expecting the behavior something like this, right? Then now software asking me how you want to consider buckling length of this column, right? So there's the two things we have to consider. First one is asking whether it's a braced element or bracing element, right? Braced or bracing. Okay, I type it first, sorry. Brace or bracing. Okay. I delete all this one. Right. So this one we had to input it, right? Right. Whether our column on the element is brace or non-brace, right? And brace or bracing element, right? So I choose is a braced element. That means core walls going to provide the lateral restraint to this column. So in nutshell, so this column, how it's going to behave is this column laterally restrained. So I can represent by like this. This column, each level is braced laterally. So this spring represented by diaphragm. So this our flow diaphragm going to give the support for this column. Flow diaphragm. Okay. Flow diaphragm. Okay. So flow diaphragm providing the lateral resistance. So end of the day, the load going to transfer to the core walls or shear walls. Okay. That's a system I am considering, right? Secondly, so software asking how to calculate this letter the effective length or stiffness of this column. I call effective length LE, right? So how to calculate this effective length, right? You already learned how to calculate effective length, right? So basically it's depend on the this element stiffness, right? Right? So I'm not going to write the equation, it's a big equation, right? So basically it's depend on the stiffness of this element. So software asking whether you want to consider this thickness or not. That means, okay, I have a column like this. Then I have a beam like this and like this, right? So it's asking whether you want to consider this depth or not.
லாஸ்டா கர்னது தெரியலனா
Cannot see. I think you can see my whiteboard, right?
Yes, but we need to zoom out something, and then we can see.
Okay, okay, okay.
We can adjust it.
Okay.
Your whiteboard.
You can see the whiteboard, but you are saying, I don't know why, how to zoom out.
Okay, okay, we
Fit
can
to
zoom.
screen.
We can
Okay,
zoom out.
okay,
We
fit
can,
to
we can.
screen.
We can zoom. We can zoom
Okay,
out.
okay. I fit because I set a fit to screen, so it's supposed to see in the screen. Okay, so So now it's asking Sophia asking whether you want to include this structural depth or not, beam size or slab beam depth or slab depth, right? Generally, I choose this one. That means the effective length of the buckling is considered only this one. But some design code allowed to take only center to center, right? Some design code they have reduction, but Euro code they allowed to go until here. So I am going to use this method. Okay. So I'm going. Okay, that's a meaning. Okay, I think now you can see my Tekla window, right? So I click I tick all the options, right? If you don't want, you can untick it, right? Finally, sway and trip, right? So it is a lateral stability and lateral deflections, how much, right? So if you want to limit some values, then you can choose here, right? You can choose here. But I think this is something advanced topic. So if you want, you learn later on. Is if I go inside here, then I can discuss many things. So I leave it at this moment. Then it's a nominal cover. I'm providing 35 mm. You can change the 30 mm or 40 mm. Anyway, this one you can change later on. Fireproofing, I leave it. Pin load also I leave it. Okay. Now I can draw the column, right? So this column is starting from base to level 3. Okay. So just pick up the point and click OK. Okay. Okay. Sakharan, I think someone is still coming. I send back to you as a course, so you can start to admit them. Give me a minute. I'm doing everything.
Okay.
Uh, oh, okay. Sorry. Your profile and ISLBC, right? Okay. Now you can admit them. Okay. Okay. So after pickup, you see what happened, right? It's off centered, right? Because you see here it's asked me about the alignment, right? So I say it's a top, then it's a left. So so if I change to center, then it's become center, right? So if you want to place center, you can place it like this. Okay. So similarly, you can go the same setting, all are same basically. So it says alignment center to center. Alignment, let's check the alignment. Where's alignment? Okay, I think it's a center. Okay. Oh, why it's not changing? It's still top. Okay, so I think we had to change here. Let me see where's alignment. Major alignment, minor alignment. Where's alignment? Okay, sorry. Yes, under the center. Okay. So okay, I saw the column first. Drawing the column simple. Just click on the point, is automatically draw. Okay. So now we have drawn the columns or on the whole. If you want, you can see in 3D, right? Now look into it, right? So bottom is automatically play the pin support. You see? Have you seen? There's a this support is a pin. You can select the support and see the property, right? Fx, Fy, Fz. That means all forces are fixed, all moment are released, right? So force fix means all translation direction fix it. Moment release means all rotation is release it. MZ fix because otherwise it's become unstable. The torsional stiffness, torsional moment you supposed to fix it, but it won't create a big torsion on the column, but you supposed to fix it, otherwise it become unstable. That's why it's fixed, right? It's very common, right? So all columns are pin column. So now we have drawn the column. Okay. So next, okay, for base one, I finish the work. I close the base one. I serve it. Okay, I serve today. Okay, so after serve, I got to level one, story one. Okay, now you can see the column. Okay, so I'm going to draw the beams. Okay, this horizontal beam, I make okay, the horizontal direction I provide the beam, one-way beam. Then vertical direction I am going to provide the one-way slab. That's my system. Okay, I choose my beam size is 9 meters. So rule of thumb I choose is around 1000 by 800 depth, 1000 width and 800 depth. It's a band beam. Okay, so these things we can go ahead. I think next week onwards, I'm going to discuss about the structure of framing. Then I can explain to you how to use the beam sizes and slab sizes. Now I just take some based on my some rule of thumb. So now we are going to row the beam. To row the beam, click on the beam, right? So I click the drop down. You can see beam and precast. So we are not going to discuss precast. So it's a monolithic and second cast institute. So I click beam. After that, come and see the properties. Characteristics beam, right? I already explained what's the meaning, right? Type concrete or so on, okay? That's all are similar, right? We are not going to rotate the sections. Same concrete grade, or if you want, you can reduce it. Okay, for beam, I go with grade 30 concrete, right? 25, 30 for beam, right? Select the bar. Okay, if you want, you can change the bar, your preference, right? Then go to section. Okay, I create a new section. Okay, my beam width is 1000, depth is 800. But you don't bother about this one first. Just I choose based on some my rule of thumb. We can discuss about this one later on, right? How to choose a size before go to the actual design. Okay, alignment, right? So this one, right? You see, we have major element and minor element, right? So we suppose we are going to place on the top center to center. Let's say we are going to place center to center. So I say just say change to center. So bar type is similar, no difference. Releases, right? So releases. I come later on these releases. We had to discuss how the releases carefully. Design and analysis and design control. This one I think not important at this moment. Design parameters also we can discuss later on. Cover, nominal cover, right? So it's based on the concrete grade and exposure condition. You can choose. Okay, I leave it 30 mm. Okay, so I'm going to row the beam first. So drawing the beam, click on the center of the column to column, right? Then you can continue to row the beams. Continue until the end. Okay, so now you have finished your beam, right? So one continuous beam, but it's divided on the column location. Okay, so you select. So after select, you can see there's a group name, right? So it's a one group beams, right? So it's a one name. Okay. If you want, you can divide also if you want. Okay. If you bring the cursor, right, you can see this one 1B1 dash 1, 1B1 dash 2, dash 3, dash 4. Right. When we do the design, right, it's become one continuous beam. So if we keep it this method, right, then we can name it easily. 1B1 is a 1B1 continuous beam. Understand? Okay, so now let's think about the releases, right? So releaser is a big design concept, but I want to put it very simple way, right? So someone may have a different opinion, but I'm not going to argue on this one. It's purely based on the engineer design. So it's an engineer supposed to decide whether it's a moment transferring joint or not moment transferring joints, right? If you ask me how to design this one, right? To me, it's a purely engineer decision, right? Same joint, some engineer detail as a pin, some engineer detail as a moment, right? It's a way of detailing, right? So end of the day, if your column can carry the moments, it can be moment joints, right? The thing is, a column whether can take the moment or not, right? But general practice, I'm just talking the general practice, right? End connection be right to make as a pin, end connection. But this one is a continuous joint, so we leave it as a moment. So that means the expected bending moment diagram, I am expecting this way. So this one 0 moment. So uh, right, okay, this is my center of the beam, right? Okay, I start from here 0. So it's going here cocking moment, then come to sacking, cocking here, sacking. But actually here it can be like this. Sorry, it cannot be. It may not be like this, right? Because even though it's a equal span, because of the pattern loading, you may see the differences, right? It's depend on the arrangement. Okay. So anyway, this moment is not a big differential moment is not big, but here I am going to make as a pin. But it's a way of analysis, right? It's my own decision. I can say it's my own decision. Some engineer may have different opinions. They can make as a moment join here. Okay. In order to release this one, select this beam, right? How to release us, right? So, right. We had to make sure that we have select this beam. Okay, so when you bring the cursor here, right, you can see first one is 1B1, second one 1B1 dash 1. So we supposed to select 1B1 dash 1, right? And okay, now you select this beam only. Okay, now go to releases. Okay, first end, I start from here. So first end, I make it pin. Okay, second end is continuous. Okay, similarly, I go here B4 1B14 end. This one is a second end because I start from here to here, right? Second end, I make it pin. Okay. Okay. I think now on the pin fix, I leave it to you. You guys can decide it because this is not a design class. This is just modeling things, right? So I leave it to you, right? Then, okay, now you can start the row here also, but another way is copy. You can copy and paste it. So I just select all beams and copy, right? Go to edit, you can copy, right? So you copy the beam, 1B1 beam, you are copying, okay. Right? Okay. Fire click. Give me a second. Okay, pick the reference point. So it's asking here. I cannot see the window. Okay, so it's asking picked up a reference point. So I select the reference point, then bring down. So now you had to pick the new point column, right? Similarly, you had to go down and pick the column points, right? So it's same as our Tekla, sorry, Revit structure. So select the point and paste it. Okay, finally press escape. So now you have run all the major beams. Okay, you have run all the major beams. So now if you want, you can go and see in your 3D, right? So 3D look like this. Okay. So if you don't want to see this one, right, you can see the wireframe also actually. Wireframe view. Later I see it. We can see the wireframe also. Okay. So now I'm going to draw the H beam also. H beam I make it simple. It's a 6 meter span. So I make it 300 by 600 or 500. Okay. So go to model. I model the beam. So same setting. Only I change the member size. So width is 300, same as column, and depth is I make it 500. Anyway, this one going to carry only the facade of wall loads. It's not going to carry the slab load. Alignment, I make it center to center, right? Releases, all fixed. We can do it later on. Okay, so I start from here. So all the way, draw it until the end. Okay, finally enter. Okay, so similar, come here and draw it. Right, finally enter. Okay, so now let's go and do the release. So similar, same concept. This joint and this joint, I'm going to release it. So I select this beam 16-1, right? Let's go to release the first end. Then similarly select this beam, release the second end. Okay, then select this beam, release the first end. Select this beam. Oh, sorry. Select this beam and release a second end. Okay. Okay. So now our floor beams beam systems are okay. Then let's go and draw the slab. Okay. So slab, right? So concrete, right? You see column, beam, wall become later on. I do some walls now. Okay, we do later on. Slab. So slab, you click the slab option, right? There's a many slab, right? So normal one way or two way below slab system, right? Beam slab system. We had to draw beam on slab. You have the precast slab, sorry, flat slab, right? Or precast slab. It is a beam slab system, so we had to pick up this one. Okay, you see, it's a one click in the bay. You see, create slab, select bay, right? You can click like this. So before create a bay, right, slab, right? We have to modify the property. Actually, slab, right? You have a different property. You see, you can rotate it. Okay, the X direction 0 or 90. This is a spanning direction. Okay, so later after place it, we modify this one. Include in diaphragm mode. This slab, whether you want to include as a diaphragm or not, right? So if I think you are familiar diaphragm, what's the meaning of diaphragm, right? So basically, diaphragm help to transfer the lateral load to the core walls, right? So whether you want to include or not. If you don't include, then you have to think about your lateral stability system. So generally, cast into slab we can consider as a diaphragm. Precast sometimes cannot, but cast into definitely you can consider as a diaphragm. Overall slab depth. What is the depth? Okay, 6 meters span. I provided 200 thick slab. Okay. Others, I just leave it as it is. Overall properties. Okay, this one overall depth 200. The concrete crate also I reduce to 30, same as column. So sorry, same as our beam, but I cannot find out here 30. Here I can find out 30. Okay. 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 Diaphragm option. Someone go with semi-rigid. I think there's no much difference. You can go rigid or semi-rigid, right? Then okay, one more parameter. Decomposition. Okay, whether it's a one way or two way. So I strictly is a one way. I decide one way, so I go with one way. So I place it. Just click on the bay because we already enclosed by the beam, right? So it's automatic pick. So click, just click. So you see the direction, right? Because this angle is 0, right? So it's a 0. Later on we can modify it. So I change it to 90 here, right? So I change 90. Okay. So select this one and rotate to 90. Rotate angle 90. Okay. So now we have successfully row our one way slab, right? Our system simple, band beam and one way slab. Okay, understand? Okay. So as I said earlier, all column be set as a braced element, right? So we want some core walls, right? Core walls. So I decide to place a core wall here, this area. So in order to do this, I delete these slabs. Or one way, what you can do, actually you can modify these slabs. Okay. After click this slab, right? Sorry, you can modify this para edge actually. Okay. Sorry. Wait. Pick up. Okay. You see, click here. I bring to here. Okay. Click on the edge and you can modify it. Okay. Then I select the beam 3, number 3 only, and delete it because I am going to roll a full wall here. Delete. Similarly, I delete the beam 3 and delete it. Okay. So this whole area I am going to capture by wall side. So I am deleting the column also. Right. So this column also I am deleting. Okay. So column also I am deleting. Okay. So now let's see how to row the walls. Okay, so there's a core wall option also. You can draw the full box wall, but I'm going to roll one by one. So mesh wall, right? So uh the wall, right? So if you are familiar building design or RC wall design, then you basically you know this one, pier design and uh, this one we call is a mesh design or find element design, right? Pier design and find element, what's the difference, right? It's a big topic. If I go inside, I cannot finish it. So generally we do the pier design. Generally we do the pier design, but you can go with the finite element mesh design also, but it's not recommended. If you do the finite element mesh, then you had to be careful when you do the analysis and you had to look in the all peak stresses, right? Normally we do only for certain building, very complex building, but general symmetric building, we go with the pier wall system, right? Okay, so here come back and see similarly same as column, right? Start from base to go top, right? So we had to go base, right? So we had to roll the here, wall here. Okay. Then mid pier concrete. You have what we want to set this concrete crate. I leave it. I leave it to 200 thick. Wall 200 thick is okay. Or if you want, you can go 250 thick, right? Extension. If you want to extend, you can extend it, but I don't try to extend it. wall actually no need to release. Okay, another important thing is wall, right? Normally considers a fixed. Base is fixed, right? Because wall is, we expect wall supposed to act as a vertical cantilever under the wind load. Suppose act as a vertical cantilever. So wall always must be fixed at the bottom. Right? Someone will argue, I don't want to argue, there's a frame action, so it can be pinned, or is your own decision. It's engineer judgment, right? But I make it fixed. Right? So I just row be wall one by one. Another wall, right? This direction, okay, you can draw the box, but it's not practical, right? So normal, I am going to draw maybe this one 6 meter. I'm going to draw only 4 meter. So now what I want is I want one construction line here. So I am going to draw the construction lines. So construction line, I pick up here construction lines. So construction lines, I want to take offsets parallel, right? Quick parallel. So from here, right, I go how many meters below 2 meter? Let's say 2 meter. Plus F2 and 2 meter, enter. Right. So now you have this construction line, right? Okay. Let's go and draw the wall. Right. So I draw the wall here. You can draw for exercise, you can draw the box wall also, no problem. Right. If you don't want the long construction line, right, you can actually you can stretch it like this also. And okay, this one also can like this. It's look better. Okay, so now let's go and see in 3D how it look, right? So you see, it's automatically play the support for the walls, right? Automatically plays the support. If you want to edit it, you can go and edit it here, right? Okay, if you want to edit, you go here, wall support, right? You can change it here, right? Okay, so first story finish. Okay, sorry. This area, I had to complete my beams. Okay, so I quickly row the beams, one beam. So beam size is I maintain same 1,800, right? So here to here I make it pin, both end pin. So I select the releases, both end I make it pin. Okay, then quickly row the slab also. Okay, now you see I cannot select the way because this is open, right? Okay, but you can, okay, one way is you can draw the dummy beam here. There's a one way to do it. So I'm going to draw one dummy beam. So actually there's a beam. Okay, so what I'm going to do is I'm going to make 250 by 500 beam. Okay, okay, you can make it pin connection. Okay, now go and draw the slab 90-degree. Okay, so now you have drawn everything. Okay, okay, so now we have finished one story, full one story finishes, right? So what you can do is you can copy everything, right? Go to the edit and copy, right? When you copy, you can choose it. What are the elements you want to copy it? Let's say we don't need column and we don't need wall because we have drawn from base to top, right? We don't need wall, right? We don't need a construction line also. Support also we don't need. So basically what we want is slab, right, and beam. Okay. Then is asking the picking point, right? Oh, sorry. Now I am going to copy to the next level. Okay, so there's another way to do it. Okay, let's say this is identical, right? Is identical. So that's why I want to explain. Okay, go to the model, construction levels, right? So here you see there's a one option called source, right? So let's say this is, if you say level one and level one, right? So that means this is a copy of level one. This is a copy of level one. So, okay. So, well, this one I make it unit. This one I may make it as a level one. So it's a level one. So same as level one. So we click OK. So now go second story. Okay. You automatically copy it. Third story, not copy it. You have the columns and bolts. Okay. At this moment, I leave it. You can draw, we can draw things, or if you want, I can copy the same thing here. If you go second levels, make it level one, this automatically copied. So the 3D, you can see nice, uh, nice three-story building. Okay, let me see why this one not copy. This P not copy. Level two, sorry, level two. Oh, there's a beam. Okay, okay, there's a beam. Okay. 3D cannot see. Okay, 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 that's a B. So all columns are supported. Okay. Oh, this beam deleted. Sorry, I haven't noticed this beam is deleted. Okay, let me draw again. Okay, so I select this beam. Okay. Similarly, other floors also I draw it. Okay, I will draw automatic draw because if you change here, it's automatic draw there. Okay, so now we have a three-story building. Okay, that's we can see in 3D. Okay, so let's go and apply the loadings. Right, let's go and apply the loading and do the analysis. So next class we can start to do the design. Okay, loading. Okay, this class I am going to explain two types loading first: dead loads and live loads. That means gravity loads. Wind load we start next class. We have only half an hour, right? Because if I start the wind load, then cannot finish it. Okay, in order to apply loading, right, you have to go to the loads. Right, in the below you can see. Okay, then you can see, click this drop down, you can see there's a different type of the loading. Self weight, right, excluding slab, that means beam column self weight, then slab self weight, debt, service, impose. Okay, what's the difference? Okay, how to apply the loads? Let's say this building is office building, right? Client not going to give you the loading, right? You supposed to decide it. Client say, this building is office building, I want tile finishes, right? So what are load I want to apply it? The question is what is the load I want to apply it? Okay, so if you refer the EC1 code, right? For office building, your live load between 3 to 4 kPa. or 2.5 to 4 kPa, it's different, right? So I'm going to use 3 kPa. So this one called is a live load, right? So impulse load, easy one terminology is a impulse load. So impulse load is 3 kPa. So what's the meaning of dead load and services? Okay, dead load means it's a building weight, right? If you need the finishers, right, like a tile finishers, right? But if you want to do the tiling, right, you had to do the screening, right? You had to lay the screed, then only you can lay your tiles, right? Generally, we make the provision for 50 mm thick concrete as a dead weight. This one we call as a superimposed dead load, STL, right? 50 mm concrete weight is equal to 1.25 kPa loading. If you can do the calculation, concrete weight is 2.25 kilogram per meter cube. So 50 mm it's become 1.25 kPa, right? Services means below the slab, right? You had to connect your services. Let's say you have the lights, you have the fans, you have the M&E pipes and so on. Also, you may need the ceiling, floor ceiling, right? Generally we make 0.5 kPa for the services, right? So we are all are area load. So we are going to apply the area load on the slab. Then slab load distributed to the column, beam. Then beam loads go to the column, column load go to the foundation. This is our load flow diagram, right? How load going to flow into the foundation, right? So we are going to apply load on the slab as an area load. Okay, so this is a terminology. So if you want to understand more, then you got to go and click the load cases, right? So here now you can see all load cases. Actually, you can add your own load cases, right? If you want to add, you can add it. If you have any new load cases, you can add it, right? So this is all I standard load case. I'm using standard load case now. Let's next week we can discuss about the will load. So then we can add the load. Okay. Now look at the screen. Self-height, right, is automatic calculate. If you untick it, then software don't include the dead weight, right? So it's automatic calculate. Then we don't need it. Now see dead and services, right? Type is dead. That means this considers a dead load. When you do the load combination, this one considers a dead load. Impulse load considers impulse load. Okay. Then there is the options. Okay, whether you want to include in the load reduction, impulse load reduction or not. If you want, if you tick it, is consider. Otherwise, you don't consider. Pattern load, whether you want to consider the pattern load or not. Impulse load, pattern load, right? This pattern load pattern, this is actually not necessary for us because we are not doing the precast. So what we can do is we can consider the pattern loads, right? Then load group we don't need now at this moment. Combination, right? You can add your own combination or ask software to generate combination, right? So I go and generate the combination. I click generate. Then is this windows pop up. Now you have to choose it, right? Okay, I think you all of you are familiar easy zero, how to do the combination, right? So if you're not familiar, go back and refer the easy zero. There's a two equation. Equation 6.10, 6.10 A and B, right? So it's a very long equation, right? I put in simple term. I write on in the screen. Text. Okay, but equation 6.1 saying, right? This one saying your dead load factor, right, is based on Singapore or UK annex 1.35 dead load plus live load is 1.5 live load. Is simple term. Actually, it's a pretty long equation with a different annotation, but it's if you summarize it, it's become like this, right? The 6.1 A and B, 6.10, 6.10 A and B, right? There's a two equation. There's two equations. Actually, you can lower down the factor of the dead loads, but you had to satisfy the two conditions. Actually, I forgot the equations, right? Something say 1.25 dead load plus 1.5 live load or something. I forgot it. This one I couldn't remember. Something like this. But to keep it simple, normally we use these equations. But if you want to do the more precise analysis, you can use these two equations, right? Okay, this is the meaning. Okay, so I choose it 610. Delete all previous. Anyway, we don't really select it, so you can delete it. Then here, this is a different type of combinations. Okay, in the Eurocode, right? There's a 3 or 4 types of the combination they have it, right? Equilibrium conditions, geo combination, right? Accidental combination, seismic combinations, right? So if you don't want all these one, right, we can ignore it actually. You can ignore it, right? I don't want your combination. Okay, let's say I'm going to the foundation, so I select only your combination, but I don't want accidental combination. I don't want your seismic combination. Sorry. So I select only geo combination. Next, then is sewing. So first two are the strength combination, third one is a geo combination. STR means strength. You see 153 dead load G plus 1.5 Q live load. Okay, this one also similar, but they apply in the EHF, equivalent horizontal load. RQ means reduce imposed load, right? So when you have the pattern loading, they reduce the loads and apply it. So it's called RQ, reduce the imposed load. Then it's automatically calculate the imposed load, sorry, equivalent horizontal load and apply it here. Okay, so we go next. Right, this one we don't need anywhere. It's the imposed load factors, right? If you want to change it, you can say, but we don't need to change. Next, okay. Then direction. Which direction we supposed to include the equivalent horizontal load? We had to include all directions, so I choose all direction. Geotechnical. If you want, you can ignore it, but I choose it at this moment and finish it. So it's already generate a design combination for you, right? Right? Then you don't need to do yourself. It's automatically generated. So you see, first one only the gravity, others are gravity plus lateral. Okay. Second one, you see, there's a two. Okay, when you select here, right? Strength and service. That means it's calculate the service also. If you don't want service, you can untick it. If you don't want to calculate the service, you can untick it, right? You can untick. You can calculate only the strength, right? If you want service, then you can click it. Right. For geo combination, no need the service. It's geocom, it's all included inside, right? So this one basically, if you want to check a deflection or crack, then only you need the services. Otherwise, you don't need services. Okay. So I think that's all the services, load cases and load combination. So I click OK. Right. Now, if we come back, right? If we come back and see here, right? So it's okay. This imposed load, right, is actually is a pattern loading. It's a reduced imposed load. So if you click on the combination, then you can see your combinations. All generated combination you can see here. Okay. Okay. So now already we done the modeling. Also, we already set up the load combinations, right? So we are going to apply the loads. So what I'm going to do is first load case. I say apply the dead load. That means in the finishes weight 1.25 kPa dead load. So this one I'm going to apply on the slab. Okay, for slab, right? You can see here. Right? This is a load, area loads, right? You can apply on the slab, right? You see, when you select a slab, right? You create a slab load which apply to the slab, right? So it's apply on the slab panel, right? Into your slab panel. So area means you can it's a slab, but it's you can select a particular area and do it, right? That's it's a meaning, right? If you have a panel, small panel also, you can do it. Then if you want a small patch, you can apply the patch load, right? So okay, if you want to do one by one, you can select the slab load. So better do on the slab load. So I click the slab load. So it's asked to pick up the load slab items. Before that, I set up the loading. So it's asking the direction, set directions the load. Load how much loading? 1.25 kPa. Okay. So I click on the slab. So whole slab is selected because whole slab is the same thickness, same name. Then load is applied. Okay, let's say undo it. Okay, area load. If I select the area load, same. So I had to do one by one the selected area. Okay, understand the difference? Slab means the vertical slab. Uh, okay, now I go to second story and show it. You see this slab, right? All is the same name basically, right? All is the same name. Sorry, same thickness, right? So it's applied on the same thickness, all loading. But if you want to differentiate, then you have to go to the area load and apply each panel, right? So basically, end of the day, it's a load same, but it's a different way of applying, right? Okay, in case if you want to modify this load, right, go to your cursor here. Can you see the AL? AL means area load. You can see in the screen, right? Area load is showing it. Now you select it. So it's area load is selected. So now you can change this figure if you want, right? Let's say if you want to select the slab, right? Press the arrow on the keyboard, select the slab. Now your slab is selected, so you can change. If you want to change the depth, you can change it. So this is the way you had to select it. Okay, let's say now, if you want to select the beam, then you had to arrow down and you can select the beam. Okay, easy. So area load also applied now. So if you go back to level 2, the load not captured. See, load not captured, right? So now we had to apply the loads. So load already captured because by is captured, we set as a unique. So it's already captured. So if you want to test, you can test here. The third story also, you can check it. So in order to check, right, you have to choose your loading here. What is the load type, right? So dead load, you are checking the dead load. So if you select the dead load, it's already applied. If you select the services, it's not applied yet. Okay, so dead load applied. So I am going to apply the services now. Services load, right? So same way, now I am going to use slab loading. So I use 0.5 kPa, 0.5 kPa slab loads. So applied, right? You can go and test other flows. Okay, done. Save the model frequently. In case crash it, then you cannot do anything. Okay, now I am going to apply the live load, impose loads. Impose load, okay, you can choose either slab or area. So I go area. So impose load, I decide 3 kPa for obvious spelling. 3, select the slab and apply it. So all flows is automatically applied. You can go and check it. You can check the magnitude also. You see 3 kPa. 3 kPa loading. Okay. So now we already finished the modeling. Also, we already apply the loading, right? So our model is ready to analyze for the gravity load. We haven't applied any lateral loads. It can calculate automatic lateral load based on the equivalent corresponding force, but we don't apply the wind loads, right? So first I analyze gravity load first. The next class we start the wind load. Okay, to go to the analyze menu, now you have to choose which analyze type you have to do it, right? So as I said, I'm going to cover only first order linear analysis. Simple building, we don't need non-linear analysis. We don't need second order analysis, right? We need only the first order static analysis, right? So I click first order static analysis. right? So it's asked to ask me to select the combination, whether I want to run all the combination, all the load cases or not. Okay, at this moment I select all, but normally you don't need to select all. It's depend on your analysis tab. You can change it. I select all first. Now it's running the solver, right? So it's showing the progress, you see, is successful, right? There is no any error, is succeeded, right? So if you want to see your status, right? If you go to the status here, you can see here, right? The validation, right? Is there an error? Let's see the error. Any? Okay. No, it says this is non-linear. Non-linear. We don't do any non-linear. Okay. It's analysis, we have done it. Design, we haven't done. Bin load, we didn't do it. Rip check, we didn't do it. So basically, it's already done. Right. So building already analyze. Okay. So after analyze, okay, let's see the value based on the combination, right? Okay. Basic combination, right? Okay. I select the combination, right? So now I want to see the results. So let's say I want to see the bending moment or shear forces, right? So here you see one D results. That means this one D results means all column beams results are captured here. 2D results means slab. When you do the slab analysis, okay, mostly this one is suitable for the flat slab. So when you do the flat slab analysis, you can see the results here. Okay. If you want to take the foundation results, foundation reaction, you can take from here. Okay, so the column axial forces, moment, major, minor, and so on, you can select it, right? So now I'm going to look into the moment, major moment, right? I click major moment, right? So it's showing the diagram. It's not very clear, but it's showing the diagram. So I choose a beam, this beam. I right click on this beam. Right, right click on this beam, right? Okay, we can go to, you see, can you see the open member view or load? And okay, you can go either open load analysis view or open member view. I go to here, right? So you see the particular beam, right? In the continuous beam, you can see all the forces, the design force, shear force, and bending moment, also deflection in one screen. Okay, it's very easy, no? Right? That's why I wrote as a one continuous beam. Then it's a one look, you can see everything, right? Actually, here now you can move this bar, right, and see the actual forces. So, right, when I move this one, you can see here the forces is changing, right? So if you want to look at the actual figure, you can look into it here, right? So the forces also, you can see how much force decompose it, right? This force, how much you can see, right? See here, the applied load, kilonewton per meter. If you have doubt, you can do the own calculation and check it, whether it's correct or not, whether it's decomposed correctly or not. Okay. So if you want to filter it, let's say I don't want to see the deflection. It's gone, right? It's gone. So dimension, I don't want to show the dimension, make it clear, right? Or if you want to see that, well, if you want to print the screen clearly, you can remove this one and print it, right? It's look nice, no? If you want to create a report, you can create a report like this. So in one look, you can see all forces. Understand? Okay, now you see, this is my expected bending moment diagram, as I explained earlier, right? This is my expected bending moment. So we can create it, right? Right. So some people don't want to make it pin here, so they can see some moment here, but it's my decision, so I make it pin. So this joint to me, I don't transfer any moment. So my column design very straightforward and it's simple. I don't need to design for such a big moment. So my moments are very minor. You see these differences, right? Only 15 kilometer. This difference is quite high. Okay, it's not high, very high. Only 27 kilometer. So we are transferring only 27 kilometer to the column. So it's quite small value. Okay, so now if you want to look into the other force, if you want to look at the forces for the other combination, you can see here. You can change the your combination and see what's the values, right? Finally, you can see the envelope. Oh, I didn't create the envelope. Okay, so later I show you how to create the envelope. So you can see the envelope as well. Okay. Okay, so this is a way we can look into the detailed bending over diagram and CFOS diagram. Okay, now come to this point, right? So we have done the only linear analysis. There's no other analysis. Okay, see two options: strength factor and service factor. As I said earlier, we have created a combination for strength and service factor. Service factor normally is 1. Strength factor 1.35 or 1.5, right? So if I click, let's say in the deflection, I want to see for the strength factor. So I click strength factor, right? You see bending momentum, CFOs reduce, and axial deflection, right? Only 6.7 mm. Right? This is not a correct deflection, right? This is a basic deflection based on the full section, right? For where the concrete elements, right? You suppose carry the crack analysis and do the deflection calculation. This is not an actual deflection. Actually, this is called as a full section deflection. Okay. Okay. So this is a one. Okay, now you can examine whether you have the mine axis bending moment or not. Click the mine axis, right? You see, there's a bending moment very, very small because of the slab effect. When you do the final element, sometimes you have mine axis bending moment, but the magnitude is very small, it's negligible. You don't need to worry about this. Similarly, you can look at the axial force. Look at axial force, right? There's a similar axial force because the slab acts as a diaphragm. So there's axial forces, but value is very small, negligible. Okay. This is a column, right? Sorry, this is a beam. Similarly, column, if you want a column, right, you can do it. Column. Okay, column actually you cannot do it this way. Column, you have to do the sections. Okay, I go and do the section later on. Okay, now you understand how to do how to check the whole bending moment diagram. Actually, before go to the design part, you have to check the whole bending moment diagram and make sure that your designs are okay. Okay, here I showed you one. Okay, this beam. Let's go and see this beam. Okay, here you can see small bending moment. Actually, it's a quite significant bending moment because this joint I did not make it pin. In the model, I did not make it pin. So this considers a fix and transferring the moment. See here, I am transferring a very big moment. Right, 6 is more than our span moment. It's very big moment and transferring. Right, so these are the things, right? If you do like this, right, then we had to be careful when we do the joints. When we do these joints, a second span, right? Second span, this point, this joint or this joint, 1, 2 second span, this joint. These joints, right? When you do the joints, right, we had to be careful on this joint. Okay, so that's why as much as possible in the end one we had to make it pin. Okay. Okay, now I am going to create some sections, right? Because I want to look at the axial force and bending moment of columns and walls. So I want to create a section. So in order to create a section, you go to model and create frames. You see frames. Create frame and see here, pick the grid lines, right? So I pick the grid lines. This I think already created. I create all the frames. This already created, right? So now after I finish this one, press escape, go to the project browser, you can see frames and is arrange the frame based on the grid lines. Okay, now I am going to see this grid line file. So frame file. So this is a frame file. Okay, so analyze view. Oh, I can see results. Oh, results, sorry, results. Okay, in order to see the result, right click on here, see the results view, right? Now, you can see the results view. Okay, I am going to see the axial forces on the column, right? So I had to choose a load combination here. Okay, now you can see the axial forces. Okay, so how much axial forces transferring here? So each column you can see. If you want to see in detail, right click on here, go to load analysis view, then you can see here what is the axial forces, how it's transferring from roof to foundations, right? Right. Similarly, if you want to see only the axial, if you don't want dimensions, you can remove dimensions. Then torsional moment I don't need. I want the axial forces only. Okay, you see axial forces. Okay, if you want to see the major moments, you can see the major moments. Minor moments, you can see. You see the moment is not big. As I said earlier, this is my expected bending moment diagram. So I can able to achieve it. Make it pin here. So this is all continuous moment. So our bending moment diagram look okay. Okay. So actually, before go to the design, you guys supposed to go through all the results. Okay, even though you don't need to look in the numbers, you had to check the pattern, bending moment diagram, shear force diagram pattern, whether it's look okay or not, whether it's look what actually you want it or not, right? So let's say sometime if so only bending moment like this, right? Then you know something wrong. It's not right, right? Then you had to go back and see it, why it's look like this. Okay. So you can change some equivalent horizontal values and see. So it's same bending moment diagram. Okay. Okay. Similarly, you can go the other sections. Okay. Let's say wall, right? We have the wall here, wall frame 3, right? So you can see the results, right? So 2D section, all line. Okay. So to get the wall results, you can click here, wall result line, right? So here select the log combinations, right? Wall results line. Oh, wait. Let me see. I haven't click the forces here. Major force. Okay. No results. Why no results? Axial force 0. Let me see. Mm. Yes. Let me check why this wall resource not showing. I'll check this one. Something looks strange. Why it's not showing? But it's already designed, so it's already analyzed. It's no problem. But I'm not sure why it's not showing. Okay. So to go, if you want to get the moment right, you can see all the moments, right? Right. Okay. So okay, one interesting question you may ask me. Okay, these are whole walls, right? Then why this bending wall look like this? What's the reasons? This is a wall panel. Why this look like this? The reason is, you remember when you do the modeling, what I choose is mid-pier wall. That means this one considers a one pier at the mid and apply the stiffness of this pier and this software analysis. That means this one considers a one beam with the stiffness of this wall and do the analysis. That's why it gives the bending wall diagram, bending like this. Understand? So this is the way this one doing the analysis. That is called mid-pier wall analysis, right? If you choose the mesh, right, so it's totally different. Result is totally different. Okay, so that's a different. That's why it's showing like this. Okay. Okay, now I can see it here. Here I can see this. Oh. Okay, okay. Now I can select it. Okay. So, okay, this is a wall for axial forces. This is axial forces on the wall. Okay. So similarly, moment of the wall is this one. Minor moment, major moment. Okay. So we had to choose from here. Yes. Okay. So this one. Now you can choose it. Okay, understand? Okay, I am going to stop at this point. So only one more thing we had to cover is bill load. Next week, I will cover the bill load, how to apply the bill load. After that, we go and do the design. Okay, each member is design. Actually, design is very fast, but I want to spend the time on the detailing. Design is a one click. Let's say for this beam, if I want to design, just right click, right? Design member or check member. I just click design member, right? Oh, here, axial process. Okay, this next week I discuss about those. So you can design is faster. Okay, this one click you can do the design, but I want to spend the time on detailing, how to detailing and how to extract the detail from the software. Actually, you can extract the rebar detail from the software to AutoCAD. You can export AutoCAD or you can export Revit. Then you can easily use it. You don't need to go back and redo the drawings. So next week I spend the time on that one. So beam detailing, column detailing, and wall detailing, how to do it. Okay. Okay. I think that's all today. If anyone have any question, ask me now. Okay, I give you my personal email address. If you have any doubts, you can contact me. If you have any doubts on the software, how to use it, then I write to reply to you as much as possible. Okay, I share in the WhatsApp group. If you want anything, you can say contact me. Okay. Anyone have any doubts? Okay. If not, then sir, we can bind up today. Then we can meet next Tuesday, guys. Let's continue on the Tekla Structural Designer. Okay.
Okay.
Okay. Thanks. Bye.